In this section, we will explore the Python data types. Let's quickly review what we will be covering. Numeric types for handling numbers, string type for working with text, sequence type like strings and tuples, dictionaries for key value pairs, sets for unique collection, boolean values for logic, and special none type. Let's begin by understanding the core principles of Python's type system. It's based on four principles: dynamic typing, allowing the variables to change types; runtime type determination, checking types as code executes; an object-oriented model where everything is an object; and flexible type interactions between different data types. Let's explore Python's numeric data types, the foundation of mathematical operations in programming. Python offers several numeric types to handle different kinds of numbers. Integer type for whole numbers, floating point for decimal values, complex numbers for advanced mathematics, both signed and unsigned numbers, support for arithmetic operations, comparison capabilities, and bitwise operation. Let's create three variables to demonstrate each numeric type. They are all dynamically typed, and when we add an integer and float, the result automatically converts to a float. Similarly for multiplication, Python also supports advanced operations such as floor division, modulus, double asterisk for exponentiation. Go through the code to get an exact idea. Now let's explore Python's string data type, which handles text and character data. Strings have several important characteristics. They are immutable, meaning once created, they cannot be changed. You can create them either using single or double quotes. They fully support Unicode characters. They come with numerous built-in methods, and they support operations like concatenation, replication, indexing, and slicing. Let's see the different ways to create strings. First, we create S1 using single quotes and S2 using the double quotes. Both methods are equivalent. And to find the length of string, we use the len method. It tells us Python has 6 characters. The upper method converts to uppercase, transforming Python all to capital letters. String slicing lets us extract the portions. S1 of 0:3 gives us the first 3 characters, pyt. And to find, the find method locates the substrings. It returns 0, indicating py starts at the beginning. The replace method creates a new string with substitutions, replacing Python with Java. Next, the string manipulation. The concatenation joins string together and creating the word Python programming. The multiplication operator repeats strings, the duplicating the Python twice. And finally, the individual characters or slices, accessing the first character and the specific slice. There are many more methods for strings which can be learned by the course of time. Let's explore Python list, one of the most versatile and commonly used data structure. List in Python has several key characteristics. They maintain the order of element as inserted. They are mutable, meaning they can modify after creation. They can contain duplicate elements. Their size can change dynamically, and they support various methods for manipulation, indexing, and slicing. Let's create a simple list with 3 numbers. We use square braces. My list assigns 1, 2, 3. The append method adds an element to the end. And let's see the list now. It outputs 1, 2, 3, 4. The index method finds an element's position. 3 is at index 1. The sort method arranges elements in the ascending order, though our list is already sorted. The reverse method flips the order. Now our elements are in reverse order. And just like the strings, we can use indexing and slicing, accessing the individual elements or extract the portions of the list. Python lists are versatile, dynamic, and allow efficient storage and manipulation of ordered, mutable collection of elements. Let's examine the Python tuples, an immutable sequence that offers some unique advantages. Tuples have several distinctive characteristics. Like lists, they maintain the order of elements. Unlike lists, they are immutable. They can contain duplicate values. Their size is fixed upon the creation. They support fewer methods than lists but offer better performance for read-only operations. Let's create a tuple using parentheses. My tuple assigns 1, 2, 3. When we print our tuple, we see its elements enclosed in the parentheses. The count method shows how many times an element appears. The number 2 appears once in our tuple. The index method finds an element's position. 1 is at index 0. We can access the elements using index notation and slice tuples just like list, extracting a portion of the tuple. Python tuples are immutable ordered collection that store multiple items efficiently with fixed structure and minimal memory overhead. Now let's explore Python's range object, a powerful tool for working with sequence of numbers. Let's look at the key characteristics of range objects. They represent ordered sequence of numbers. Once created, they can't be modified. They are immutable. They are commonly used in for loops and iterations. They are memory efficient, only storing the start, stop and step values. And they support slicing operations just like list. Here we create a range object that will generate numbers from 0 to 4. My range assigns range of 5. We only specify the stop value of 5. When we convert our range to a list, we can see all the numbers it represents, 0 to 4. The step value denotes how much we increment by each time. By default it's 1 and we can verify by checking myRange.step. The start value shows where the sequence begins. Since we doesn't specify 1, it defaults to 0. The stop value of 5 represents where our sequence will end. Remember, the value it isn't included in the sequence. And finally, like list, we can slice our range object. Understanding the range objects is crucial for efficient Python programming, especially when working with loops and sequences. Here is our section on binary data types, where we will explore how Python handles raw binary data. Let's look at the key components of binary data in Python. We have bytes, which are immutable sequence of integers, byte array, a mutable version of bytes, memory view for direct memory access. These are the crucial for low-level data handling, and we will see important distinction between immutable and mutable type. Here we create a bytes objects during a literal. Byte underscore data assigns b hello. Notice b prefix that designates this as bytes data. Now we create a byte array from our bytes. Byte array of b hello. This gives a mutable version of the same data. Understanding these binary types is crucial for working with files, network protocols, and low-level system operations. Let's explore dictionaries, which store data in key-value pairs. Here are the key features that make dictionaries so useful. They store data as key-value pairs, like the real dictionaries. They are mutable, meaning we can modify after creation. They provide extremely fast lookups using hash tables. Their size can grow or shrink dynamically, and they come with many built-in methods for data manipulation. We create my dictionary with curly braces. Name John, age 30. Note the curly braces and colon separating key from values. To access a value, we use its key. MyDict of name returns John. This lookup is extremely fast regardless of the dictionary size. Adding a new key value pair is straightforward. MyDict of city assigns New York. The dictionary grows dynamically to accommodate new data. We can check the dictionary's length. Len of MyDict shows that we have 3 key value pairs. To get all keys, we can use mydict.keys. This is useful for iterating through the dictionary. The get method is a safer way to access the values. MyDict.get of age returns 30. Unlike the direct access, get won't raise an error if the key doesn't exist. To remove a key value pair, we can use the pop method. mydict.pop of age removes the age key and return its value. And another way to delete is using the del. Del mydict of city. This removes the key value pair but doesn't return the value. To remove all the items, mydict.clear can be used to empty the dictionary completely. Dictionaries are essential for organizing and managing data in Python, making them a crucial tool in Python programmers' toolkit. Now let's explore the Python set. Sets are unordered collection of unique elements. Unlike lists, they don't allow duplicates. They are created using the curly braces and they are mutable, and they support mathematical set operations like union and intersection. First, let's create a set. My set assigns 1, 2, 3, 2. Here we define a set with duplicate elements, but since set only store unique values, the duplicate 2 is removed. The union operation combines both sets. The intersection method finds common element, which in case is 3. In order to modify the set, we have add method that inserts an element. Since 4 is not already in the set, it gets added. And the remove method deletes a specific element, and the discard method also removes an element, but unlike remove, it won't throw an error if the element doesn't exist. Pop method removes and returns an arbitrary element since the sets are unordered, and the clear method removes all elements, leaving us the empty set. In this section, we will explore Boolean and none types in Python. Boolean represents two values, true or false. The none type, on the other hand, represents the absence of a value. These are commonly used in conditionals and logical operations. Is valid is assigned true, which is a Boolean value. The variable result is assigned to none, meaning it has no value. In Python, 1 is considered to be true when converted to a Boolean. On the other hand, 0 is considered false. Booleans can also be converted to integers. True becomes 1 and false becomes 0. And we can also convert Booleans to string. Here true is converted to string true. So Python has various built-in data types including numeric, int, float, complex, sequence type, list, tuple, range, string, and set, dictionary, and Boolean types, each serving different purposes. Understanding these data types helps in efficient memory usage, data manipulation, and implementing logic in Python programs.